Hello and welcome back to Codeblaze. This is going to be the last episode of the series creating voxel chunks in Unreal Engine using blueprints. In the last episode, we finished up with this whole big piece of blueprint code that's responsible for our noise map generation. In this episode, we'll be tackling mesh building, which is the final thing that we need to do. So we are going to be implementing the remaining helper functions, the isEmpty, getPositionInDirection, and the check functions. Now if you take a closer look on the names of these functions, you can get kind of the idea of how mesh building is going to work. So basically we'll be iterating over the whole blocks array, and for each block we'll be checking the neighboring blocks in all the 6 directions, whether they are empty or not. If they are empty, we'll be creating the faces. And we'll start by implementing the getPositionInDirection, and this is something that I've already implemented. And don't get intimidated by all these values. It's a pretty simple function. So the inputs are a direction of the type a direction enum and a position, which is an int vector, and this outputs a result which is going to be a position of type int vector. So basically we switch on the direction, so depending upon the type of direction we either add one or subtract one to the corresponding axis. So for here we have the forward direction, which you can see is this return node, and basically we add 1 to the x value and return y and z as it is. Now if you take a look at the direction enum that we created in the first episode, I have mapped it out. So the forward direction corresponds to plus x, right direction corresponds to plus y, back direction to minus x, left to minus y, up to plus z, and down to minus z. So according to that map, I basically implemented this function adding 1 or minus 1 on the corresponding axis, and there's nothing special about this function, so you can implement this on your own. Next we are going to implement the isEmpty function. Also this getPositionInDirection isn't modifying any of these member variables, so it's a pure function. So for isEmpty we are going to have an input which is called block. This would be of the type of our block enum, and what we'll be returning would be a boolean, which will be the result. So we'll basically take this block and compare it to an enum value, which would be all of the empty blocks that you have in your blocks enum. So for me that's the null block and the air block, and if you have more you can compare to those, and you will basically be ORing them or use the OR operator on all of them, and this is what will be returned here. So that's our isEmpty function. Again, this isn't modifying anything on our state, so this will also be a pure function. And finally we'll be implementing the check function. Now this check function as isEmpty function are dependent on the use case. It depends on the type of generation you want. For my use case, I want there to be faces on the edges of the chunk, so that is these faces here. So on all the 5 directions, that is forward, back, left, right, and down, I'm going to have these faces, except for the up direction, because up direction is mostly comprised of air blocks, so it won't make practical to have faces here on the up direction. So to do that, the first thing that we'll input would be a position. Again, this would be of type int vector, and we'll be returning a boolean, which would be our result. Okay, so I'll break this position up using that, and we'll be checking the 5 directions whether it's exceeding the size or going below 0, since our chunk indexes should be between 0 and 16 on each of this axis. So we'll get this size variable, we'll take x and see whether it's greater than or equal to size. Since when we are checking the neighboring chunk, neighboring blocks, and if we are on a block which is at the edge of a chunk, and the neighboring blocks index on either of the axes may be greater than 16 or less than 0, and in those cases we want to create a face, since that would be the edges. So if it's greater than the size, I'll copy this block here on x or y. Okay, or if it's less than -1, less than equal to -1, Again, these comparisons depend upon the type of generation you want, so you can modify them according to your use case. So the comparison with -1 happens on all three. So these are 5 comparisons corresponding the 5 directions. I'll basically OR them. I'll add 3 more pins, and if this is true, any one of them will be returning true, so the face will be created. So we'll do a branch here and we'll connect this here. So if this is true, we'll return true. If this is false, we'll do another branch. Here we'll be checking the up direction. If this is true, we'll return false and return. If we don't check here, it will return false. So to check the up direction, we basically say if y is greater, z is greater than equal to the size. So that means if this branch condition is true, we return false. And if it's something that has not been trapped by these two branch conditions, then that means the block is somewhere in the middle of the chunk. In that case, we'll be getting the block using the getBlockIndex function. We'll split the structure, we'll get the x, y, and z value. Then using the blocks, we'll get a copy. And then we'll check whether this block is empty or not. Again, isEmpty is the function that we implemented, and whatever will be this value will be returning that. So we'll add another return node and plug this in here. So that's our check function. Again, this is not modifying anything on the state, so it would be a pure function. Now if you take a look at our helper functions, other than create face, every other function is a pure function, so do make a point of that. Next, we'll go to our construction script and finally implement the mesh building. So we'll break this second execution pin of the sequence. We'll break this pin also and move this out of the way for now. And we'll bring in the execution pin and do a for loop. So first thing we need to do is iterate over the blocks. For that we need 3 for loops corresponding the x, y, and z direction. So we'll connect them. So these are 3 nested for loops, and the last index is going to be size -1, since the for loop runs inclusive of the last index. Using this indexes, we'll be able to get the block index. So we'll use the getBlockIndex function, split it, pass in the x, y, and z value from the indexes of the for loop, take the blocks array, get a copy, and with this we are basically iterating over all of the blocks. Now we are going to check whether the block we have gotten is empty or not. So if the current block that we are at is empty, we don't need to do any generation, since air blocks and none blocks won't have any faces. So we can do a branch statement here and reduce a bit of computation. So if this condition is true, we don't do nothing. If this condition is false, then only we go into this for each loop which generates faces. I'll recombine the structure pin since we'll be splitting that. Now when we are going over this direction, so we'll be checking the neighboring blocks. To do that, we'll be using the get position in direction. So direction is this enum value and position is our x, y, and z values that we have here. We can even, rather than splitting everything, we can use make vector and do that, so that will actually reduce the number of wires and clean it up a bit, but we'll do it this way now. So we get the position in that direction and then we check that position and we get a boolean value, and depending upon this boolean value we'll be doing a branch. So if the check is true, we will be creating our face. Now the only thing that's left is providing the position value, and since our cube is of 100 units length, we need to offset our position by 100. To do that, we'll be multiplying x, y, and z by 100. And again, if I would have just created a vector, this would have been a single multiplication, but whatever, it doesn't matter now. So we'll be multiplying our x, y, and z values by 100. That's this, and we'll be splitting up this position and wiring this up. You can obviously clean up your blueprints as much as possible, creating macros and everything, so there's practically no end to it. But it's a good idea if you're doing some big project, which this certainly isn't. Now if I compile this, it may look like it's stuck, but that's because it's going through a huge number of iterations here. And if we take a look at the viewport, zoom out a bit, you'll see we have our chunk being generated. You may need to zoom out a lot depending upon your speed. So with that, we have a chunk mesh being generated, and if we go inside, we don't have any of the internal faces, so that is a really optimized way. So we don't have any hidden vertex position or hidden faces. And if I just save this and go into the world, you'll see this is our chunk YT, the actor that we just created in this series. And if I move this around in X and Y position, you'll see the mesh is modifying. It may be a bit laggy since it's going through a large number of iterations to regenerate the mesh, but you can see the mesh is changing depending upon the position of the chunk actor in the world. So you can place around 10-20 of these actors. It will only lag during the placement, and once the generation is done, it's pretty performant, rather than the previous tutorial in which I had hundreds of cubes being spawned, which taxed the GPU also. But once the mesh is created, it's not as heavy on the system. So that's it for this tutorial series, and I hope you liked it. I'll be doing a similar tutorial series in Unity using the new burst compiler and the job system, so that would be a pretty performant multi-threaded way of doing this chunk generation. And multi-threading is something that can be done in Unreal Engine, but I have no idea how to do that. And I may do another video going on further ideas that you can implement in expanding this whole voxel system. Also, if I am able to do the whole UV and textures thing, I may make a video on that. So do subscribe so that you get notified on when these videos come up. If you have any other suggestions, or if you want me to make tutorial series on something else, leave them down below in the comments, and share this video with your friends. It really helps me out. So thanks for watching. Bye.